All right, hello everyone. I think we're going to start right now. I see a lot of people have come in, and just for those of you who just arrived, just so you're aware, Arpin is a bit busy for the start of this, so I'm gonna kick this one off, but he'll be back by the end, and so with that, I'm just going to launch right into our presentation for today. So just to orient ourselves within the larger series that we're doing here of workshops, this one is specifically, it's going to introduce geometry and facade workflows with Ladybug. And these two sessions I'm going to hold, basically part one and part two, are mostly just on sort of simple analyses that you can run with Ladybug in early design, which you should really max out and use before going to the more advanced stuff like energy simulation, daylight simulation, etc. So with that, just so you guys know, again, I mean, this is a reiteration from the previous webinars that I've already given the intro webinars, but we're going to only be working with Ladybug in the course of this presentation today. And specifically, we're going to be mostly working with those components that analyze geometry, that essentially use the climate data that's available as EPW format and help analyze and evaluate our geometry in particularly for early design cases. And just so you're aware, if you weren't here for the first few ones, we covered visualizing weather data and analyzing weather data in the first two sessions that I held. And yeah, and after this one, we'll be moving, after these two on geometry, we'll be moving to Honeybee. All right, so with that, just wanted to let you know the schedule for today, and you'll see that it's going to be about hour and a half to 2 hours, probably going more to 2 hours as you see what I've laid out here. And it's everything that we're going to be covering today is just going to be working with solar radiation. Every one of these things is solar radiation based. And in that sense, the types of evaluations that we're going to be doing are related to energy, essentially, the energy use of the building and the size of our energy systems, our thermal energy systems. And so I'm going to hopefully get through all the stuff that relates to radiation today, and then the next geometry exercise immediately after this one will be covering things that relate more to occupant comfort, like direct sun and glare, views to the outdoors, and those types of things. So that's just so you guys have a sense of what we're covering, and we're going to go through some basics about radiation, about how to visualize and understand it. We're going to do some studies on radiation, each for two different types of use cases, and then finally we're going to do some actual generation of facade geometry based on our solar radiation studies. And what you see, what I'm trying to do here, just because we've given a lot of tutorials already on simply just how to use, how do you run a certain type of study. But what I'm really hoping to communicate to you guys here is a sense of the typical useful applications of the workflows, the things that I'm running, on a bi-weekly basis, that the workflows that I have found most useful as I have applied Ladybug and Honeybee to design processes. And I mean, and the idea of this is that the value of software, it's not really so much in knowing how to run it, but how to use it usefully to apply it and solve problems with that software. And maybe just, an example of this would just be that, I could teach a 4-year-old how to double-click on a Microsoft Word icon and bash the keyboard to make a bunch of letters. And I could say that that 4-year-old knows how to use Microsoft Word. But what really makes it useful is once that 4-year-old learns how to read and write, once they learn how to usefully apply written language to a bunch of different cases. And so that's why I usefully apply it to solve problems. That's hopefully what I'm going to try and impart to you guys by the end of today. And just so you guys are aware, I mean, there are actually many, many different uses of radiation. I mean, these are just a few that I'm pointing at here that I use typically. Just so you guys have a sense of when the stuff we're working with in this exercise is applicable to design. And you could use it to size, to orient photovoltaics and solar hot water panels. You could use it to help design passive heating systems like in greenhouses. You could use it to orient your building. You could use it to inform how you design outdoor awnings to shade people and be comfortable. And then finally, could use it for building shading. These are just a few of the many ways that it's useful. And in particular, we're mostly going to be focusing on these three today. And actually, outdoor awnings are going to be at the very start of the next one when we start to engage thermal comfort and occupant comfort in relation to the sun. So really, in particular, we're going to be looking at using radiation, how you use it to inform your building orientation studies, and how you use it to define your building shading and glazing systems today. And just so that we're all aware, I mean, most of you are already well familiar with what solar radiation is, but I feel just because there's probably a bunch of users who are just coming into this, these types of analyses with environmental design. So I just feel I should give a very just brief explanation of what solar radiation is, because it's going to be the whole topic of today. So at the core of what solar radiation is, it's the same thing as energy. It is the energy that comes in from the sun. And you can measure that energy in joules or in watt hours. Watt hours or kilowatt hours are the same units that we use to measure electricity that goes into our buildings. So really what we're talking about here is the energy that comes in from the sun to your building. And there are two slight variations on this that we're going to be working with today. One of which is what we'd call solar power as opposed to solar energy, and that is just the energy divided by the time. So it's the rate at which energy is coming in. You can imagine it that way. And the units that we usually use to measure this are a watt, which is the same thing as a joule per second. And so that's more an application of how much is coming in at a given period in time per unit of time. And then finally, the one that we'll be working with most today is actually one where we'll take those joules per second, those watts or watt hours, and divide them by an area. So divide them by, for example, a square meter to say this is the amount of sun that comes in per second on a given area. And so the term for that is called solar flux. And you'll see that, some of the solar energy is very specific to a given situation. It's the total energy you can imagine that comes in a time period, the total energy that your building receives or something like that. So it's very specific to cases. Whereas things like solar flux are averaged over a time and over a surface. And so they're a bit more generalizable and help you compare apples to apples a little bit more easily. All right, so with that, I think that's all that I have here as far as an introduction. Yeah, there's some more things. I'll come back to this presentation in a bit. But with this, I want to jump into the presentation, the actual walking through of the components today. And you guys, ARPAN should have sent out to many of you who are listening here. We have a Rhino file that we're going to be working with. It's a very simple, though. It's just a bunch of block geometry. If you don't have the Rhino file with you, you can easily just create something very similar just with the box command and typing that a bunch of times in Rhino. But I'm going to use this just because it's, because we have an interesting site to work with here that provides different levels of shading for the building that we're working with. And so if you guys are following along, I'd recommend opening up this Rhino file or creating just a simple set of boxes. And then finally, ARPAN should have also given you the Grasshopper file that we're going to be working with today. Whoops, let me close that. I've got another Rhino window open here. The Grasshopper file that we're going to be working with, and that, well, actually that's not open on my machine yet, so I'm just going to type Grasshopper and open that. Actually, I thought it was. Let's see. For some reason, all right. For some reason, it looks like this one isn't displaying. All right, I'm going to jump over to here then, and I'm just going to start a brand new file, or rather, I'm going to open up the file that ARPAN should have given you, which is called just Facade Workshop Start File, and open that, and you'll see that it looks like a very simple definition, but it's got this pretty monster component, which is actually just a group of other components. And what we're going to use this for, if I turn the preview on here, is that this monster component is generating a building massing based on a set of parameters. And if you, you don't necessarily need this file to work with in order to run all the studies. Again, ARPAN So I think sent it out to everyone who has them, who registered. But I mean, really, all that you really need is just, I mean, all the changes that you can make can be done manually just as well. Again, I mean, at this point, this is just a box that we're running with here. Okay, and I see also it seems like some people might have registered at the last minute too. So we'll try and make sure that we send out the files again to everyone else, just so that you have something to work with. But if not, all that you can again just make. We're going to be looking, all of these things can be run just on a simple box, just as easily as they could be with a bunch of other things. So I mean, you can create your own geometry, and you'll still be able to follow along relatively well and get most of the principles. But the reason why, I mean, I wanted to have you guys look at this just because this is a very common thing that we're doing early in the design process, which is that we create a parametric building massing based on a set of parameters that allows us to explore a whole range of different options. So for example, you'll see here I can change if I drag this slider, I can change the width of the building. I can change, maybe let's say, the length of it. And we have a few other things that we can play with here, notably an overhang distance that you can see here of a few feet. I'm sorry, again, the whole file is in feet. So for those international folks, I apologize for the IP stuff, but I mean, it's good at least to show how to. I mean, I spent the whole last set of tutorials working in metric, so it's only fair, I think, to have a file in feet. And we have a few different parameters here, like shearing, a bunch of things that we're going to work with. But I'm just going to start with just a box so that it's very easy for you guys to follow along. All right, so 100 foot by 100 foot box here. All right. And again, you guys can, if you have this, you can play around with it. But you see that all this component is doing is spitting out a bunch of geometry that we're going to work with and giving us a floor area. Awesome. And if you guys are curious about how this is actually constructed, you can just double-click on the cluster and see that everything inside here is actually just made with native Grasshopper components. And the reason is I clustered it because I don't want you guys to get overwhelmed by the sheer number of native Grasshopper components here. So I'm just going to save and close. And I just wanted you guys to get a sense that you can build parametric massing models like this. It's not required in order to be able to understand what we're doing today, but this is just so that you have an example down the line, if not at present. All right, so with that, we've got at least a site here. We've got some parameters of massing that we're going to explore, and I'm just going to move this out of the way for a second. Now let's get to the actual Ladybug part, which involves importing climate data. So the first thing that you guys know, what we always have to do when we start a Ladybug file, we're going to drag and drop Ladybug onto the canvas, because that's the command center of all the other components. All the other components reference this. And then actually I'll show you, because last time I showed you how to automatically download an EPW file with this. So I'm going to show you another workflow today, another useful way to open EPW weather files. And that's if you already have one on your machine right now. Hopefully a lot of you saw the previous one, so you understand how to actually get weather files. But there's a simple component here called Open EPW Weather File. And it takes a Boolean toggle. I just double-clicked there and brought up a Boolean toggle. And if you set it to true, it'll open a window so that you can navigate to an EPW file that exists on your system. Now, I mean, hopefully, if you guys need a refresher on how exactly to get EPW files, that's all covered in the first tutorial series. But for now, I'm just going to navigate to find this Boston weather file that I have here on my system. And I'm doing this just to show you guys that you can open EPW files without being connected to the internet, which this component kind of, because it asks for a URL, this one kind of requires. So all right, so we have, after we've opened an EPW file using this, you guys will see it's now giving me the file address of that file, that weather file on my system. And now I want to bring in all of this data into Grasshopper. And then just like we've done in all of the previous workshops, I'm going to use the Ladybug import EPW component to do that. And so I'm just going to connect that up there. So if you guys remember, if you had attended the last workshop, you remember that we looked at these actual values of solar radiation that come in here when we import the EPW. And we had used these to try and account for sun falling directly onto people in a thermal comfort analysis. And so you saw that, all right, we understand this general format of the way that radiation is stored in the EPW file. So it comes in as, it was a little bit of header that tells you what it is, and then for every single hour of the year, you have the amount of solar radiation that comes in units of energy, in watt-hours per meter squared. So in that unit of solar flux that I mentioned previously. And so when you see that there's clearly no sun out during at night, and then in the middle of the day, it really ramps up to a lot of solar radiation. So we have direct normal radiation, which is that sun that is coming directly from the sun, from that place where the sun is in the sky. We also have something called diffuse radiation, which is all of that solar energy that is diffused across the sky, coming from all different parts of the sky. And then we've got a few other things like horizontal infrared radiation, this one is diffuse. And then we have global radiation, which is just the total amount that's falling onto a horizontal surface. So kind of both direct and diffuse combined. And so you might start to think about this, that we have hourly values for both sun coming directly from the solar disk and from all over the sky. The weather file, you guys will also remember, includes a lot of information about latitude, longitude, so that we know where the sun is positioned in the sky. And actually, I mean, as you guys, I'll just do this. This is a refresher from last time, but if you drag and drop the sun path onto the canvas, and I connect up my location here, you'll see in the weather file, and give it a few seconds, you'll see within the weather file a sun path will be drawn. And so you can see that we have all that we need to calculate solar position, and we have the actual intensity of the sun as well. It's stored in these radiation values that we have coming in here. So together with these two, we can actually build up from the EPW file an entire picture of what the solar energy looks like across the whole entire sky dome. And that's what we're exactly going to do right now. And we're going to use a special component that does a special function, essentially, to take all of this, take this location data, take this direct radiation, this diffuse radiation, and unpack it and assemble for us an entire image of what solar energy looks like across the sky. So I'm going to take this Gen cumulative sky matrix component. It looks like a bunch of yellow circles, and you'll see that instead, because it actually works directly with the raw data that comes in the EPW file, we actually don't have to use any of this imported data. I can just take the EPW file directly and connect it up to here. And I'm just going to do this. You guys don't have to set this Boolean to false here, but I'm just going to do this so that you guys see, if this is the first time that you're running this component, this is what you're going to see. So really all you have to do, don't worry about connecting this, but if you connect this Boolean toggle to true, you'll see a command window pop up, and some functions will start running on your computer. And what's happening here is that EPW file is being decompressed and unpacked into an entire image of what the sky looks like, and gives us. And we're going to visualize this in a second. But this is essentially what's running here. And I know there's also a lot of times I've given tutorials where people will see the command window pop up and they'll just exit out. Don't exit out. It's running something very useful for you. It's not some rogue other program. This is the actual component that's running right here. So yeah, make sure you don't connect that out and exit that out. And if you do accidentally exit out, all that you need to do to make sure it reruns is actually set this Boolean toggle to false. And that'll make sure that it runs everything. And the only reason why I connected up this Boolean is because if you've already run that function once, you don't need to run it again. You only just need to bring in all the data into Grasshopper, all of the data about the sky. So that's why you don't need this running it the first time. This is only just to say, rerun the entire function before bringing the data in there. And if you already have data, you don't need to have anything connected there. All right, so you'll see what comes out of this is initially a little bit confusing. So it's just a sort of a Python class. It doesn't really have too much information, but I can tell you guys what this actually is that it's a huge set of data. It's a big, big matrix, a big chart of all of the radiation values of the sky for the entire year. And if we want to actually get a sense, if we want to visualize what this whole big matrix looks like, we're going to use this other component called the Ladybug Select Sky Matrix. And I'm just going to drag and drop this. And you guys see that it takes the cumulative sky matrix as an input. So I'm just going to connect that up to there. And you'll see out of this, I'm not actually going to touch any of these other inputs because they're not required to run the component. And I'll say it one more time just so you guys know the convention, that if it's a dash in front of the input, that means it's required to run it. If it's a dash anywhere else, like on one side or both sides, it's not required. So with that, I'm going to look at what I get out here. And what we're actually seeing is we're getting, again, a format that's pretty familiar. We're getting a header that tells us what this is, but we're getting units of kilowatt hours per square meter. Instead, however, very importantly, instead of getting 8,760 values, one value for every hour of the year, we're only getting 151. So we're getting values, these are actual energy values for different patches of the sky, for different parts of the sky, essentially. And so, I mean, I know that's a little bit abstract at first, so let's try and visualize this so that we can understand exactly what's going on here. And in order to visualize this, I'm going to drag and drop the Ladybug Sky Dome component onto my canvas here. And you'll see it takes the selected sky matrix as input, so I'm going to plug in that selected sky matrix there, and I'm going to set a Boolean toggle to run it to true. All right. And then with that, give it a few seconds, and now I'm going to go, you'll see a lot of the things coming out of this are just curves and meshes and things that are visualized in the Rhino scene. So I'm going to go, after a few seconds after this file finishes running, I'm going to go over to my Rhino scene, and you guys will see that, and actually I'm going to hide everything else just so we could really see what's going on here, and turn the preview off on these things. Preview off. Okay. Well, you see what we're getting here is we're actually getting values of kilowatt hours, of amount of solar energy coming from all these different parts of the sky. So we have a visualization that's actually a lot like the sun path. But whereas the sun path is only telling us the position of the sun, this is actually telling us the amount of solar energy coming from the different parts of the sky. And maybe just to make this really explicitly clear, I'm going to change the scale here. I'm just going to type quotation mark and 2 in order to give me a panel that has 2 in it. And then I'm going to connect that to scale in order to scale the sky dome by 2. So you can really see it aligned well with the sun path. So you see that, as we might expect, those patches of the sky where the most solar energy comes from align pretty well with actually where the solar position is, according to the sun path. But however, you see that the amount of solar energy that we get in the other parts of the sky isn't zero. Not all solar energy is coming directly from that sun position. Some of it gets diffused across the sky, and so whenever we run studies of radiation, and actually I'm going to turn the preview off here, it's important that we that we understand that the whole entire sky dome matters. It's not just the position of where that sun is. And importantly, I've only been looking at this first dome right here, which is the total radiation. But you see that just in the same way that the weather file is organized into diffuse radiation and direct radiation, so too are sky domes organized into diffuse radiation, which you can see is a bit evenly distributed across the sky, and then direct radiation, which only comes from that position of where the sun is. And so our total that we have here is just the sum of these other two domes. Whoops. I'm just going to zoom back to the extent so we can see that. Okay. All right. So you guys have a bit of an understanding of how radiation is different from just looking at a sun path, which you guys are already familiar with from the previous tutorials. But now let's actually get into really trying to do some analysis with this radiation, not just visualizing it, but really trying to evaluate our designs using this radiation. And so I'm just going to set this Boolean toggle to false for now, just to turn the sun path off. And let's see, I'm going to type show to bring all my geometry back. All right, So there's another thing that we can do. Let's say that we want to use this solar radiation that's in the selected sky matrix, and we just want to use it to help us understand how we should orient a building on this site. Like, what is the best direction that we should be facing in order to make sure that we minimize that sun, which we don't want, but maximize that sun that is really useful, that heats our building up in winter. And so in order to do this, I'm going to just full screen grasshopper, and we're going to use something called the Ladybug radiation rose. And if you drag and drop this onto the canvas, it's a very useful type of visualization that, just like the sky dome, it takes a selected sky matrix as input. So that's exactly what I'm going to do right now. And we'll just connect this up here, and then you'll see the other required input is a Boolean to run it. So I'm going to take a Boolean toggle by double-clicking, searching, and connecting, run it there. And then you guys should see, I'm going to ignore all the other inputs for the time being, but you guys should see in the Rhino scene that we get, and actually I'm going to hide the geometry. I didn't even need to show that. I'm going to show exactly, what this visualization we're getting is. And you know what, to make it perfectly clear, let's go to top view. Okay. So what we're seeing here is that for each and every direction, each and every 10 degrees here, we're getting a visualization of the amount of radiation that comes from that direction. And specifically, the kind of assumptions that are under the hood is that if you have a surface that is facing due south, this is the amount of solar radiation that you're going to get from that due south surface. If you have a surface that's facing due east, this is the amount of radiation that you're going to get. And this is the actual amount of solar energy in kilowatt hours per square meter of area that faces that direction. And again, you see, just like the sky dome, it's organized into a diffuse radiation, which is coming, it's more circular. It's coming from all over the sky. And then we have direct radiation, which is mostly just coming from where that position of where the sun is in the sky. And our total is those two added together. But now you guys may be starting to ask, all right, so we've got, this visualization of all solar energy for the whole year. And, in one sense, maybe, looking at how solar energy is useful for the whole year, that's useful for things like solar panels, like photovoltaics, because you care about how much total energy you harvest from those solar panels over the whole year. But most of the time, if we're going to say, like, use a radiation rose like this to orient our building, we want to be sure that we distinguish between radiation that is helpful to our building and that helps heat our building in winter versus radiation that is harmful to our building and that forces us to run our cooling system much more intensely in the summer. So I'm just going to do a very simple, show you a very simple way of trying to select out just the solar radiation that we want or we don't want. And so I'm going to use that again by using this selected sky matrix component, using the analysis period input of this. And if you guys were in the previous sessions, you guys know what the analysis period is already, but this just helps you select out data that is just for a certain time of year. And it's specifically meant to take the input of this other component called the Ladybug analysis period. And I'm going to drag and drop this onto my canvas. And I'm going to say my from month, so it allows you to specify a time from a certain time in the year to another time in the year. So let's say we only want to look at the solar radiation that is harmful to our building. So I'm just going to take an analysis period for the summer condition. So I'm going to type quotations and then 6 and enter in order to specify a from month. And I'm just going to connect that there. So we're going to be starting in June is what this is saying. And then I'm going to be going all the way until September. So I'm going to double click and type 9 going to September. And then our from day is going to be from 21. I'm going to, because the day starts on the 21st, the summer rather starts on the 21st day of the month. And I'm going to connect that up there. And what you'll see, what all that this is putting out is a little set of text that tells us, okay, start from 6/21 at 1 a.m., go to September 21st at 24. And if I connect this analysis period up to, maybe I'll make sure that we can see the Rhino scene, up to the analysis period here, you guys should see now you'll get a different looking total radiation rose. And you see that, all right, if we want to orient our building in order to minimize the amount of harmful sun that we get, well, it seems a little difficult to avoid because that harmful sun comes from all these different directions. And it's actually, I mean, it comes more intensely from the south than the others. But I mean, I guess if we really want to try and minimize this, probably the best way, because this is more narrower than it is wider on each side, we probably want to orient our building north-south, essentially, in this type of situation. And we can do the same. Let's say that we're not necessarily interested in using the sun for, we're trying to minimize the harm.